same domain and codomain. F is mapping from R to R, defined by f of x is equal to x square. See the problem. F of x is same. F of x is equal to x square. In first subdivision also f of x is equal to x square. Second subdivision also f of x is equal to x square. Third subdivision also f of x is equal to x square. But first subdivision, domain and codomain is n to n, natural numbers to natural number. Second subdivision, there is integer system to integer system. In third subdivision, real numbers to real numbers. So domain also real number, codomain also real number. Now we are going to check here. Right students, how to check? F is mapping from R to R, defined by f of x is equal to x square. Now we are going to check as 1 1 injunction. Recall the definition. Different inputs, different outputs. Very simple question. Given real numbers in domain, integers is present in real numbers or not? Yes. The integers if you take an integer, it is not 1 1. So integers is also part of real numbers. So it is also not 1 1. Clear students? Best example. I am taking x is equal to plus 1 by 2. What is f of x1 plus 1 by 2 whole square? 1 by 4. I am taking minus 1 by 2 because minus 1 by 2 is also exist in real numbers. Minus 1 by 2 if you substitute. Minus 1 by 2 whole square plus 1 by 4 only. Not only that, suppose these are fractions. I am taking as a rational number. This is also rational number. I am taking irrational number. I am taking plus root 2. Plus root 2 whole square 2. I am taking minus root 2. Minus root 2 whole square 2. Different inputs, same output. Not only that, I am taking 0.1, 0.1 whole square, 0.001. I am taking minus 0.1 whole square. Like that, not only integers, if you take fractions, if you take rational numbers, if you take irrational numbers, so both positive value, negative value, if you take, will give us the same image. That's why it is not 1 1 function. We can say it is a basic concept. Integers, if you take integers, it is not 1 1. Integers is a subset of real numbers. Clear students? Integers is subset of real numbers. Obviously, real numbers also it won't exist. It is not 1 1. It is not 1 1 means you have to give it an example. Your wish, any one example. The same integers you can give an example, or you can give fractions, or you can give as a irrational numbers, or you can give a decimal numbers. Whatever it may be, you have to give. Let I am taking x1 is equal to root 2, x2 is equal to minus root 2. So f of x1, f of x is given x square. X place we have x1. So x square place also we will get x1 square. Now I am replacing f of root 2 the whole square, which is nothing but 2. Here f of x2. So instead of x place there is x2. So here also x2 square. Now f of x2 is minus root 2. Minus root 2 the whole square. So f of minus root 2 is equal to 2. Minus whole square becomes plus. Root and square cancel 2. So you are giving different inputs. x1, root 2 and minus root 2 are different values. They are not same. That means as x1 is not equal to x2, but f of x1 that is equal to f of x2 that is equal to 2. Hence it is not the 1 1 function. Not only root 2, you can take as a fractions, minus 1 by 3 plus 1 by 3, minus 1 by 2 plus 1 by 2, minus 0.1 plus 0.1. Like which pair is not satisfied, that pair you have to take an example. Clear students? Right. Suppose if you take natural number, it obeys. Sir, I will take 1 sir, 2 sir, no problem. 1 square 1, 2 square 4. x1 is not equal to x2. F of x1 also is not equal to f of x2. But when the function is satisfied, that rule means It should satisfy each and every number in that real number system. Natural number is satisfy whole numbers, rational numbers, irrational numbers, fractions, all numbers is satisfied. Then only f is nothing from R to R, f of x is equal to x square is 1 1. It is satisfied few numbers. ಸ್ವಲ್ಪ numbers ke satisfy agide. Innu ಸ್ವಲ್ಪ numbers agilla. One number agilla na it is not a one function. It is not a injective. So it must satisfy all. If it is not satisfied, which case it is not satisfied? One problem, you solved one problem in the question paper. You made it a mistake. Then you have to know that what is correct answer. Any mistake made. Where you did the mistake, you have to find out. Like if the function is not satisfied, which case it is not satisfied? That means which case it is not worked. That you give with an example. It's enough. So finally you can write f is not one function or injective. Now I want to check the surjective or onto function. Surjective or onto function. I thought surjective means simple definition is range is equal to codomain. You can find out range and codomain, you can answer easily. Sir, right. See in the problem, given problem f is mapping from R to R, f of x is equal to x square, students. Here this is domain and this is codomain. So I am writing codomain is nothing but real numbers. How to denote real numbers? Intervals minus infinity to plus infinity. Otherwise you can represent with a number line. This is minus infinity, this is plus infinity, there is in between 0. Now we need a range. What is range in this problem? I told range is equal to f of x. F of x is equal to here given x square. If you substitute any real number here, you won't get the negative value. Clear, students? That means you will get only 0 to infinity. Listen carefully. So this is a number system. This is a number line. In this number line, these are all negative real numbers. These are all positive real numbers. This is 0. Together, r minus, r plus, and 0. Together called as real numbers. Is it correct or not, students? That means minus infinity to 0, union, 0, union, 0 to infinity. These are all together called as a real numbers. If you substitute minus infinity to 0, any number, you won't get the negative numbers. That means it will be converted into positive only. 0 to infinity. 0, 0 only. Nothing but these are all values will be merged here itself. There is no negative real numbers. Why? Because they are making a square. Square model not a negative near real number becomes a positive. It is also one of the value among here. I told here minus 1 whole square plus 1. Right side 1. Minus 2 whole square plus 4. Minus 1 by 2 whole square plus 1 by 4 right side only. Minus 1 by 3 whole square plus 1 by 9 right side only. Minus root 2 whole square plus 2 right side only. So all the left side values by making square, this part is overlapping here. This is straight line. It is a straight line. This is 0. This is positive real number. This is negative real number. Or otherwise this is negative. This is positive. While making square, right? This hand is merged with here. That means negative real numbers are all come and coincide with positive real numbers. So after squaring, there is no negative real numbers. That's why this section will not come. Your answer is 0 and 0 to infinite. 0 is including. That's why it is a closed bracket. Infinite is open. That's why it is open bracket. Which include this value. Why? Because infinite. We don't know that value. How can you substitute that? Value ಬಂದ್ರೆ 2 substitute ಮಾಡಿದ್ರೆ 2 square 4 ಆಗಬಹುದು. Infinite substitute ಮಾಡಿ infinite square ಮಾಡಿದ್ರೆ ಮತ್ತೆ infinite ಬರಬೇಕು. Clear? That's why range f of x is equal to 0 to infinite. This is minus infinite to plus infinite. Is it equal both? No. So therefore range is not equal to codomain. Hence f is not surjection or onto function. Surjection onto function. So here also it is neither one nor onto function, neither injectivity nor surjectivity. Clear, students? Right. Morning, students. Now the second problem in functions, exercise 1.2. Second problem, we completed first subdivision, second subdivision and third subdivision. Both are defined with the same function f of x is equal to x square, but the domains and codomains are changes. First subdivision is f is mapping from n to n, f of x is equal to x square. Second subdivision is f is mapping from z to z, f of x is equal to x square. Third subdivision is f is mapping from r to r, f of x is equal to x square. We checked it whether it is a one-one function or injectivity onto function or surjectivity. Now we will go through fourth subdivision. What is given fourth subdivision? F is mapping from n to n defined by f of x is equal to x cube. This is so cubic function. Usually f of x square graph you know very well, but f is mapping from r to r. F of x is equal to x square, you will learn in the first period. It is represented by parabola, you will get the graph like this. If it is r to r, be careful to remember it. So f is mapping from r to r, f of x is equal to x cube, which is a cubic function. What is a graph of this function? Like this it will cut 3 different places. 0, plus 1, minus 1, like that it will cut it down. So f of x is equal to x square function graph is this. See, graphical definition I told. If it is f is mapping from r to r, f of x is equal to x square. Whether it is a one-one function means what I told. If you draw a line parallel to x axis, it intersect at most one point, that means maximum one point, but here intersect the 2 different points, so we can say it is not one straight away. Next, onto function graph I told, draw a line parallel to x axis, draw a line parallel to x axis from the each point in the codomain. Codomain means nothing but y axis, correct or not? Each point in the codomain means all the points, all real numbers. If you draw a line parallel to x axis, at least one point should be intersected. That means minimum 1 point, 2 points, 3 points, 4 points also no problem. But in above they are intersecting. Below is also their codomain points, but here graph is not there. That's why we can say that clearly it is not onto function. Understood, students? First one-one function, onto function, there is a little bit difference. One-one function, draw a line parallel to y-axis. It cuts the graph at most 1 point, it is one-one function. Next, onto function, draw a line parallel to each point from the codomain. So, each point in the codomain, you have to draw the parallel line, no x-axis. All the lines, they must intersect at least 1 point, then only it is onto. So these lines are intersected, but in below x-axis, if you see that there is no graph, here not intersected, that's why it is not onto. That's why f of x is equal to x square. Third subdivision, neither one or onto, we can say that. Similarly, it is f is mapping from r to r, but it is n to n. N to n is different. You have to take that particular point. 1, 2, 3, 4, 5 only. R to R means you can take each and every point on the number line. So if you take each and every point on the number line, you will get a graph like this. If you draw a line parallel to x-axis, it intersects only one point, and obviously it is a one-one function. Excuse me. Next one. If you draw a line parallel to x-axis, each point from the codomain. These are all codomain points only. Y-axis is nothing but codomain. Each point, each line must intersect at least one point. Yes. If this graph is extended like this graph is also extended like this. So they must intersect compulsory one point. So it is also 1, 2. So it is 1, 1 and onto f of x is equal to x cube when f is mapping from 1 to 1. Real numbers to real numbers. But it is not real number. Now we have to check in this case whether it is a 1, 1 function or not, whether it is on 2 function or not. How to check it? See. F is mapping n to n, natural numbers to natural numbers. F of x is equal to x cube. We are checking the 1, 1 function or injunction. Recall the definition. If you are giving different inputs, should come different outputs. Mathematical definition, if it is x1 is equal to x2, that implies f of x1 is equal to f of x2. Or else, x1 is not equal to x2, f of x1 is not equal to f of x2. See that different inputs. What is input? Domain. What is domain in this function? Natural numbers. So domain is equal to n, which is equal to all natural numbers. See the students, this domain we are inserting in x place. You are getting same outputs or different outputs. Check it. Let I am substituting 1 here. 1 cube is 1. 2 here. 2 cube is 8. 3 here. 3 cube is 27. 4 cube is 64. So we are giving different inputs, getting output also different. Correct or not? Later I will give with a diagrammatic example. You can see that. This is a function mapping from n to n, natural numbers to natural numbers. What is that function is x cube. So x values we will take here 1, 2, 3, 4 and so on, infinite numbers, natural numbers. Here also we are taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. But one input you can substitute here. 1 cube related with 1. If you substitute 2, 8, 3, like you will get 27, 4, 64, like that you will get. So you are taking different inputs, getting different outputs. So it is 1, 1. Clear or not? Understood, students? So x1 and x2 not equal. F of x1 and f of x2 also not equal by mathematical definition. You just check it. X1 I am taking 1. What is f of x1? F of x1 means the formula is x1 cube. I am substituting one place is 1 cube. That is nothing but 1. Next I am taking x2 place is 2. F of x2 which is equal to x2 cube. So I am replacing where is x2, there is 2. 2 cube is 8. So x1 and x2 are different elements. You are getting f of x1 and f of x2 also different. Why? Because f of x1 is 1, f of x2 is 8. So mathematical definition, what is the 1, 1 function mathematical definition? You are picking two elements. What is mathematical definition? You remember, students? As x1, x2 are the two elements belongs to the domain. What is domain here? Natural numbers, where f of x1 is equal to f of x2, that implies x1 is equal to x2. It is double inverse. If you take this, it is also possible. If you take this, it is also possible. So, reversible reaction. Either or. You can write one more definition. F of x1 is not equal to f of x2. That never implies x1 is not equal to x2. So, any one condition is satisfied in mathematically, we will say it is one function. Check it here. x1 is not equal to x2. That implies f of x1 is not equal to f of x2. Hence, it is a one function. Like this diagrammatic, we can say that. Otherwise, by seeing, you can say that f of x place you are giving different input. Input is domain. Domain is nothing but natural numbers. All natural numbers, if you substitute here, you are getting different answers. You will not get the same answer. One substitute madidra, you will get 1. 2 substitute madidra 8. 3 substitute madidra 27. Innondu number substitute madidra 27 barala. So you are giving different inputs, getting different outputs. That's why it is always one function. F is mapping from n to n. F of x is equal to x. Clear, students? So if it is a one, need not to give an example. We just write the definition. Clear, students? Right. What you have to write the definition as x1, x2 is belongs to domain. What is domain here? N. So f of x1 is equal to f of x2. That implies x1 is equal to x2, or else f of x1 is not equal to f of x2. That implies x1 is not equal to x2. Hence, f is 1 or injective function. Understood, students? Right. Now we will check the onto function. What is the definition of onto or surjective? You just remember the alternate names also, because sometimes they will ask in the exam with alternate names. Don't forget, one other name is injective, onto other name is surjective. I told one more also. If the function is not one, it is many one. Suppose you see that f is mapping from z to z, or f is mapping from r to r. F of x is equal to x square. Just now I told f of x is equal to x square. When f is mapping from r to r, you will get the graph like this. If you draw a line parallel to x axis, it intersects at least one point. Then it is at least 2 points, not 1 point, at least 2 points. It is called as many one. What is many one definition? 2 or more elements of A have the same image. So if you take +1 -1, same image, +2 -2, same image, but this function is not 1 but it is many one. So that's why what is many one means, if a function is not 1 it is called many one. If a function is not onto, it is into. When the function is not onto, range is not equal to codomain. Not equal to means compulsory it may be a subset. If range is a subset to codomain, which is called into function. Into function. Clear, students? So that proves is they won't ask in PU level. In objective level it is helpful. That's why we will concentrate and target on one injective to, onto, surjective to, bisection, and still more we have invertible function. That we will more composite function, invertible function, we need more introduction part. After complete this exercise, it is based on the composite functions, invertible functions and bisective functions, that we will discuss in later. Now we will see that whether it is a onto or surjective or not. Right, students. Checking surjective. R2 function. You just recall the definition. The given problem is f is mapping n to n, natural numbers to natural numbers. F of x is equal to x cube. Now we are going to check as onto or surjective. Immediately you recall the definition. Smallest definition. range is equal to codomain. Otherwise, each and every element of codomain, there must be pre-image, at least one pre-image in domain, or at least one pre-image in the first set. Correct or not? So, range is equal to codomain means first in this function what is range or what is codomain? This is domain and this is codomain. Correct, students? So, codomain of f is equal to n. That means all natural numbers. Next, what is range? Always I told f of x indicates the range. Range of f is f of x. In this problem, what is f of x? X cube. How to get the range? If you give inputs, there must outputs. What is input? X value. What is x? Domain. What is domain? Natural numbers. Natural numbers starts with 1. If you replace x place is 1, 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 25, it goes on. Now you can check it up. This is a codomain and this is a range. Is each and every element must be equal? No. Why? Because 1, 1, no problem. But here, 1 after directly 8. We have here 2, 3, 4, 5, 6, 7. We missed that. So each and every element is not equal to codomain and range. That's why range is not equal to codomain. Range is not equal to codomain. But what here the condition? Range is a subset to codomain. So it is into function. That's why it is not onto function. Understood, students? That is one way to explain the problem. One more way we can explain it. That also I will teach here. See here. So both sets are taken, natural numbers and natural numbers. The function f is defined from R to R. What is this function is f of x is equal to x cube. Now I can take natural numbers few because R we cannot write here. Here also I am taking few natural numbers. Right, students? What is according to onto function? Each and every element in the second set, there must be pre-image. For example, if I am taking 2 in this second set, if exists pre-image here, then the function is on. Like we will check it. So 2 is in the second set. Second set means codomain. Obviously 2 is also range. Why? Because it is onto function. Range codomain equal. So each and every element of codomain is also part of range. Now I am taking 2, which is nothing but f of x. Range. Clear, students? Understood? What is f of x according to the problem? 2 is equal to x. If you want x, it becomes cube root of 2. That means 2 to the power of 1. Can you found these kind of numbers in natural numbers? No. Why? Because this is x value. X means what? Input. That is the first set. So, if you take for this number, pre-image is this. But these kind of numbers does not exist in this set. That's why each and every element of second set should not exist the pre-image, hence it is not onto function. Why? Because onto function definition, f is mapping from a to b is said to be onto function. For every y belongs to b, there exists at least one x belongs to a such that f of x is equal to y. Second set, each and every element, there exists at least one pre-image in the first set. We will call it is an onto function. So second set, if you take 2, it does not have any pre-image here. Not only 2, if you take 3, cube root 3, that is also not exist. If you take 4, cube root 4, square root 4 means 2, no problem. Cube root 4 will not get in natural numbers, exist at all. 5 cube root 5 does not exist. 6 cube root 6 does not exist. 7 cube root 7 does not exist. 8 cube root 8 yes exists, because cube root of 8 we can write as 2 cube whole to the power of 1 by 3. In that case you are existing 2. That means if x value is 2, f of x value is 8. That's why 1 is exists. 1 we have pre-image with 1. 8 you have pre-image with 2. Between numbers you don't have any pre-image. According to definition, each and every element of set B, each and every element not possible. 1 ಕಾವಿದೆ, 8 ಕಾವಿದೆ, ಮತ್ತೆ 27 ಇರಬಹುದು, 64, 125, like 216. Such numbers are exist pre-images, but in between the numbers does not exist pre-images. That's why it is not on. Like that also we can explain it. Clear, students? Right. Now, is it exist or not? Does not exist. Now we are going to write, therefore x is equal to cube root 2 is does not belongs to in natural number. Right. You have to write, hence f is not onto function or surjunction. So here it is also not injunction and 1 we can write hence f is neither injunction nor surjunction under this domain and codomain. Not always, you remember it. Suppose if you take R to R, it exists both. Clear, students? It exists both. But in natural numbers to natural numbers, it won't exist both. Now, same problem they are given with changing domain Z to Z. We will check it, Z to Z. Z to Z or R to R. Both will be there. We will check it that. Clear, students? So see the next problem is